So in this lesson, we're going to talk about slope. And before we find slope or calculate the slope of a line, let's talk about what slope actually is. So first of all, it's just a measure of the steepness of a line. So the steeper the line, the larger the slope. The flatter the line, the less steep the slope, or the smaller value that it has. To calculate that value, we use this ratio of the vertical change to the horizontal change between any 2 points on a line. You may have already heard of this as the rise over the run, okay, where the vertical change refers to the rise and the horizontal change, or left or right, refers to the run of that line. So there's 4 different types of slope, and you can see that in the image here. Positive slope is when your slope or your line rises from left to right. We always read a graph left to right, just like we read a book, just like we do math problems when we're talking about order of operation, within adding and subtracting left to right. So anytime we're looking at lines, we refer to them as having different slopes. So in this first example on the top left, it has the bottom left goes up to the right, it has a positive slope. Positive sloping lines will rise from left to right. Negative sloping lines are the ones that will fall from left to right. So it's going to start up high on the left, and then it's going to go down as you move to the right on that graph. Zero slope is kind of in between that. It's when the line doesn't rise and it doesn't fall. It's just kind of flat. It's completely and perfectly flat. It's said to have zero slope, or sometimes it even says no slope for something like that. Now, the fourth one's a little bit more complicated and harder to understand, but we'll get into it when we start calculating the slope. And this is called an undefined slope. A vertical line has undefined slope. It means that it's not rising, it's not falling, and it's not flat. It's just not really defined. So to help us with these 4 types of slope, I have a visual for you. I apologize, it's a little bit grainy, but think of it like a mountain. Okay, and that's probably where you've heard slope, like on a ski slope, like over at Buck Hill. So what we have here on the left is, as the mountain climber is going up the hill, that's said to be positive slope. It's not straight up and down, but it is upward as he moves across the mountain. Then once he reaches the top, it's said to have zero slope or no slope because it's perfectly flat across. There's no slope up and there's no slope down. Then what we have on the back side of the hill is we have a little ski slope where he's going down the hill. That's a negative slope when you're going down from left to right. And then finally, we have this cliff that's showing it's a perfect drop straight down, a vertical drop, and that would be an undefined slope to give that description of the line.
So let's take a look at how to find the slope when you have a graph. So here we have a lot of information. I'll try to break it down for you. Probably the most important thing on this screen is in the red box. If you're recording notes and writing things down, this would be what you want to write down for how do you find slope from a graph. Slope can be calculated by taking the rise of the line and dividing it by the run of the line. So let's talk about what does it mean by rise and run. So the rise is the difference in the y values of any 2 points on a line. That's also called the change in y, as in the change in the y values. Now we don't have any numbers over here to go off of. That'll come up later. But if we look at the rise between any 2 points, all we have to do is count the vertical change. So in other words, count straight up. So if we start at the point that's lower and we count how many spaces up, like little marks here, we'll go up 1, 2, 3 until I'm to the level of the other point. So the rise here is 3 units. If I look at the rise between my second dot and my third dot, again, I count straight up vertically, 1, 2, 3 spaces, and that gives me a rise of 3 until I'm at the same level as my dot. The run is the horizontal change, the difference in the x values, in other words. So this time, if I go up with my rise, from here I want to count what is the run, how many spaces do I have to go until I get over to that red dot. Since there's 2 spaces, 2 squares, so 1, 2, my run is 2. If slope is the rise over the run as a ratio or a fraction, we can write it as a rise of 3 over a run of 2. In other words, the fraction 3/2. So the slope is a measure of how steep the line is. The larger the number, the steeper the line. Let's take a look at another graph. This time we even have ordered pairs, but we're not going to use the ordered pairs. We're just going to count rise over run. Starting at the point that's lower, the rise is if we were to go straight up until we get to the level of the other point, and then the run is when we go straight across to get to that point. So rise, run. And we just have to count our spaces. Now the rise, if I start at my lower point, it looks like it's at a height of 4. When I go up, it now has a new height of 6. So it went up 1, 2 spaces. For the run, now we're looking at our horizontal distance or even our x values. It started at an x value of 4, because this point here is right above the 4. As I went across, this point ended at 8. So from 4 to 8 is a change of 1, 2, 3, 4 units. The rise is 2, the run is 4. So when we write this out using our slope formula, the slope of this line has a rise of 2 and a run of 4. Now we can actually simplify this because 2/4 is a fraction with a common divisor. We can divide both numbers by 2 and it reduces to 1/2. The slope of this line is 1/2. Now because it was reduced, we could actually use that smaller slope. We could actually look at more points on this line. So if I go back to the first point and I rise up 1 and I run 2 spaces, notice I'm still right on the line. I can rise up 1 and run 2 spaces, and now I'm at the second point. So next I'd like you to try calculating the slope using our rise over run formulas. One thing to note, when you use the rise on a problem like this, if you go down, the rise is a negative number. If you go up, the rise is a positive number. For the run, if you go left, the run is a negative number, just like the x-axis. And if you go to the right, it's a positive value. So watch out for your positives and negatives. Find the slope. Let's start by calculating the rise. If we start at the point furthest on the left, -2, 4, my rise is actually if I go down to the level of the other point. My run is when I go over horizontally to the other point. What was the rise in this case? Well, the rise here would be 1, 2, 3, 4, 5, 6 units. However, the direction shows me that since I'm going down, my rise is a negative value. because usually rise means go up. So we use a negative number to show that it was going down. Now, what's the run? Well, the run is the horizontal change. And I was going from left to right. So if I'm moving to the right, that's a positive value. So the run should be positive 2. So what is the slope in something like this? Using our slope formula and substituting in our values, the rise was -6, the run was +2. But we can simplify this. What is the slope when we simplify our fraction? Because these two numbers are divisible and it would divide out evenly, we can actually do that. We don't need to leave it in fraction form if it divides out evenly. So -6 divided by +2 is just -3. Now this does have the same meaning as -3 over 1 in terms of a slope with two numbers, so you can see the rise and the run. And to illustrate that on the graph, we can show that if I were to go, let's see, a rise of -3 means I would go down 3 spaces, and a run of +1 means I go to the right 1 space. I would get a point on the line. If I did that again, I rise -3 spaces, and I run +1 space, I get a point on the line as well. Next, we're going to take a look at how do I find the slope from two ordered pairs. So we find the slope of the line that contains the points 4, -2 and -1, +2. And something I would have you write down is the slope formula, that m equals y sub 2 minus y sub 1, that's the numerator, and in the denominator, x sub 2 minus x sub 1. And you might be asking yourself, whoa, what in the world are those little ones and twos? Keep in mind that every ordered pair has an x coordinate first and a y coordinate second. So anytime we're dealing with an ordered pair, we have an x and a y, x comma y. Well, if I have two ordered pairs, how do I tell the difference between the two x's and the two y's? That's where our little numbers come in. For the first ordered pair, we can use 1s to represent it comes from point 1. For the second ordered pair, we can use little 2s to show it comes from the second ordered pair. So if we're going to match these up, and we're using the slope formula, we want to take the y sub 2 minus the y sub 1. In our ordered pair, that would be the coordinates we highlighted in green. So we start with y sub 2 at the end, which is 2, and then we subtract the -2. It'll look like this when we substitute. +2 minus -2. Notice the subtraction is still there, even when the first y coordinate was a negative number. For the x's, the second x coordinate minus the first x coordinate. My second x coordinate was -1, and we're going to subtract 4 from that. So -1 take away 4. When we do the subtractions, again, you can use a calculator for this. 2 minus -2 is 4, and -1 minus 4 is -5. We get 4 divided by -5. The only thing left to do is to simplify the fraction. It won't divide out evenly, so we just check to see if there's something we can do to simplify. And we can't simplify 4/5. However, we never like having a negative in the denominator, So the one thing we can do is divide. A positive divided by a negative is a negative number. The slope of the line that goes through the points 4, -2 and -1, 2 is -4/5. Let's look at a problem like this together. Here we actually have a table of values, but it's really not much different. Remember that the table of values is just a different way of arranging ordered pairs. So in this case, we have 4 different x values, where I guess technically you could call it x1, x2, x3, and x4. And you also have the y values. You could call it y1, y2, y3, and y4. Now we're just going to focus on the first two, the x1, x2, y1, y2, and we're going to substitute that into our formula. When I do this, I always like to start by drawing my fraction bar and putting in my subtractions because I know that's always going to be there. Then I can start substituting in my values. We have to be careful here. In the table, the 0 and the 2 are on the top of the table. However, when I put it into my fraction bar, I want the y values to go on the top or in the numerator of my slope ratio. And I want the y sub 2, which would be 5, minus my y sub 1, which was 1. Then on the lower left corner, my x2, which would be my second x value, was the number 2. And then my x1, which would be my first x value, was 0. Now I do my subtractions. 5 minus 1 is 4. 2 minus 0 is 2. And I simplify my fraction. In this case, they would divide out evenly. And we can leave it as, let's see, 4 divided by 2 is 2. So my slope, or m, is equal to 2. We use m to represent slope. So I'd like you to try this one. And every time I pause, answer the question on the screen to move on. So what would we label as x sub 1? -2 would be our x sub 1. What would we label x sub 2? And x sub 2 would be 0. What would we label y sub 1? Our first y coordinate would be 3. And what would we label y sub 2? Our second y coordinate is 0. So let's apply our slope formula by substituting in our values. Which number goes in the first blank? 0, because it's our second y coordinate. Which number goes in the upper right-hand corner, the second blank? 0 minus what? Well, that should be our first y coordinate of 3. On the denominator, what number would go first? Our x sub 2, or our second x coordinate, should be 0. And finally, what number goes in the last blank? Our x sub 1, in other words, our first x coordinate, is -2. When we subtract on the numerator, we should get -3. In the denominator, we should get +2. And you can double check those on the calculator. the last thing we would need to do is simplify our fraction. What would be our simplified slope? In this case, all we're looking at is the sign change, and the negative divided by a positive is a negative number. And we can't reduce the fraction 3/2, so we can leave it as the slope equals negative 3/2.